Let's step back into the shadows of the most famous equation ever written, an alphanumeric sequence that ripped the fabric of reality apart and handed humanity the ultimate keys to its own annihilation. The year is 1945, and a blinding flash over a remote desert proves definitively that matter and energy are two sides of the same terrifying coin. The man who unlocked this cosmic vault never set foot in that desert, never assembled the core of the bomb, and fundamentally despised violence. Yet his brain, an intricate labyrinth of relentless thought experiments and elegant mathematics, had single-handedly rewritten the rules of the universe. Albert Einstein is a name universally synonymous with pure, untainted genius. But the man behind the messy hair and the iconic tongue-out photograph was a walking paradox. He was a radical rebel who gleefully dismantled the most entrenched dogmas of science, a staunch pacifist who inadvertently triggered the catastrophic atomic age, and a visionary who ultimately spent his final decades completely isolated, fighting a bitter, losing battle against the very quantum revolution he helped launch. Let's dive into the deeply complex, hopelessly flawed, and utterly fascinating mind of a man who looked at a ticking clock and saw the total illusion of time itself. To truly understand the massive weight of his revelations, we cannot start in the hallowed halls of a prestigious academic institution. No, we must travel to the cramped, dusty corridors of a government patent office in Switzerland at the dawn of the 20th century. The air in this room smells of cheap ink, stale coffee, and burning tobacco. The rhythmic thud of the official stamp and the towering stacks of schematic diagrams dominate the space. Here sits a 26-year-old third-class examiner. He is a failure by all traditional metrics. He was rejected by the rigid academic establishment, severely alienated his professors with his sheer arrogance, and struggled for years just to find steady employment to feed his growing family. He is not allowed anywhere near a university laboratory. But what the academic elite failed to realize was that this suffocating bureaucratic desk job was the perfect incubator for a revolution. While mechanically approving mundane patents for gravel sorters and electromechanical typewriters, his mind was entirely untethered. He watched the massive steel trains rolling past his window, listened to the synchronized ticking of the city's clock towers, and began asking questions that a child might ask, but answering them with a terrifyingly rigorous mathematical precision. What would happen if you rode a beam of light on a bicycle? Would a pocket mirror held in front of your face still reflect your image if you were traveling at 186,000 miles per second? If you threw a rock on a speeding train, how fast is it really going? These were not just idle daydreams. They were physical, visceral thought experiments designed to break the world. Let's tear down the blueprint of classical physics that had ruled the globe for over 200 years. The reigning champion of science was the legendary 17th-century English mathematician who gave us the immutable laws of motion and gravity. For centuries, humanity confidently believed that time was a rigid, absolute metronome ticking away uniformly across the entire cosmos. A second on Earth was assumed to be exactly a second on the Sun, which was exactly a second at the distant edge of the galaxy. Space was viewed as just an empty, passive stage where the actors of matter performed their predictable plays. But sitting in that stifling office, our young examiner realized the stage was actively moving, and the universal metronome was broken. He hypothesized that the speed of light is the absolute only constant in the universe, an unbreakable cosmic speed limit. And if light always travels at the exact same velocity, regardless of how fast you are moving toward or away from it, then something else has to bend to make the math work. That something was time itself. Time is entirely relative. The faster you move through space, the slower you move through time. It was an idea so deeply offensive to human intuition that it bordered on clinical madness. In the span of a single miraculous year, this totally unknown desk clerk published 4 scientific papers that would completely annihilate classical physics. He proved the absolute existence of atoms by analyzing the microscopic jittering of particles suspended in water, a chaotic phenomenon known as Brownian motion. By calculating the exact statistical probability of invisible water molecules colliding with visible pollen grains, he ended a decades-long debate about the fundamental nature of matter. He then boldly proposed that light is not just a continuous wave washing over the universe, but is actually made of discrete, indivisible packets of energy, which we now call photons. This single, highly controversial paper on the photoelectric effect is what would eventually win him the highest international scientific honor. And most earth-shatteringly, he introduced special relativity, culminating in an equation so brutally simple it feels like a glitch in the simulation. Energy equals mass times the speed of light squared. A tiny, microscopic handful of physical matter contains a vast, invisible ocean of locked-away energy, enough to power a sprawling metropolis or vaporize it entirely. The scientific establishment was violently rocked, but he was nowhere near done. Special relativity only applied to objects moving in a perfectly straight line at a constant speed. It entirely ignored gravity. Over the next decade, his obsessive quest to incorporate gravity pushed him to the absolute bleeding edge of his sanity. He retreated deeply into his own mind, working in complete isolation, scribbling endless tensor calculus equations and relearning entirely new fields of non-Euclidean geometry until his stomach revolted from stress and his marriage collapsed. The pressure was unimaginable. If you are obsessed with decoding the hidden mechanics of our universe and the brilliant minds that uncover them, hit that subscribe button right now because we document the absolute bleeding edge of history and science every single week. Now, returning to the chalkboard, the ultimate breakthrough arrived not through a massive telescope, but through another radical visualization. Imagine a man in a completely windowless elevator falling freely down an endless, pitch-black elevator shaft. Because he is in freefall, he feels entirely weightless. If he lets go of his pocket watch, it simply floats beside him. He cannot mathematically tell the difference between falling under the sudden influence of gravity and drifting endlessly in deep space. This equivalence principle shattered the universe once again. Gravity is not a mysterious, invisible tether pulling masses together across empty space. Gravity is the geometric curvature of space itself. Imagine a heavy bowling ball resting in the direct center of a large trampoline, creating a deep depression in the elastic fabric. If you roll a small marble across the trampoline, it doesn't move in a straight line. It spirals rapidly inward along the steep curve created by the heavy ball. The Earth does not orbit the Sun because it is being pulled by an invisible string. It orbits because the Sun's massive weight has severely warped the physical fabric of spacetime, and the Earth is simply following the natural, invisible curve of that warped landscape. General Relativity was published to immediate, stunned, and highly skeptical silence. It was an undeniable mathematical masterpiece, but it desperately needed physical proof. That proof finally came during a highly anticipated total solar eclipse. An expedition of elite astronomers ventured to a remote, humid island off the coast of Africa and into the dense jungles of South America to photograph the distant stars positioned precisely behind the Sun. According to the radical new theory, the immense gravity of the Sun should warp the space around it so severely that the light from those distant stars would literally bend as it passed by, acting like a massive cosmic magnifying glass. This gravitational lensing would make the stars appear in a slightly different location in the sky than they actually were. When the fragile photographic plates were carefully developed and mathematically analyzed, the physical measurements matched his terrifyingly complex equations down to the fraction of a millimeter. Overnight, he was no longer an obscure, eccentric academic. He was a global icon, instantly recognizable, mobbed by frantic crowds on every continent, treated far more like a mystical prophet than a theoretical physicist. But beneath the blinding flash of camera bulbs and the loud adoration of millions, a deeply complex and increasingly tragic hidden reality was taking shape. Behind closed doors, the man who understood the intricate architecture of the cosmos struggled violently with the chaotic architecture of human relationships. His personal life was heavily littered with emotional casualties. His first marriage disintegrated in a toxic cloud of bitter resentment, resulting in a tense divorce settlement where he promised her the entirety of the financial reward from a highly anticipated international science prize he had not yet even won. He was emotionally detached, famously stating in private letters that he deeply loved humanity but completely despised actual individual humans. But the greatest, most devastating tragedy of his life was political. As a rising tide of violent fascism and horrific, systemic anti-Semitic hatred swept brutally across his home country in the 1930s, the world's most famous outspoken pacifist was forced to flee for his life to a prestigious ivy-covered institute in the United States. He was a man without a true home, actively hunted by the violent rhetoric of a tyrannical dictator who publicly burned his life's work and officially labeled his groundbreaking relativity theories as dangerous, degenerate science. Then came the ultimate, crushing moral compromise. In a desperately urgent, highly classified letter, he warned the American leadership that a newly discovered nuclear chain reaction could theoretically be harnessed to build a bomb of unimaginable, city-leveling destructive power, and that the enemy was already actively working on it. He strongly urged the immediate, massive funding of a highly secret weapons program. Yet he never worked on the actual project directly. The strict government intelligence agencies considered him far too politically radical, too openly left-leaning, and far too much of an extreme security risk to be allowed anywhere near the remote desert laboratories where the radioactive core was being secretly assembled. Instead, they opened a massive clandestine dossier on him, wiretapping his personal phone and physically tracking his movements for the rest of his life, accumulating over 1,400 pages of intensely paranoid surveillance. When the bombs finally dropped, incinerating hundreds of thousands of lives in mere seconds, the staunch pacifist wept. He felt a crushing wave of immense guilt, believing he had practically pushed the button himself. In his later years, the fierce rebel who tore down the old scientific order ironically became the conservative old guard, stubbornly refusing to accept the chaotic new quantum mechanics that he had paradoxically helped birth. Quantum theory strongly suggested that the universe at a microscopic level was governed by pure chaotic probability, where particles could theoretically exist in two places at once, and absolutely nothing was certain until it was physically measured. He hated this violently. He famously declared that the Creator does not play dice with the universe. He spent his final decades completely isolated from the mainstream physics community, endlessly chasing a unified field theory that would neatly tie electromagnetism and gravity into one deterministic, elegant package. He failed. The brilliant mind that had mapped the geometry of the stars died feeling like a relic, left far behind by a rapidly accelerating, quantum-obsessed scientific world. Yet, his mathematical ghost haunts every single piece of modern technology we touch today. The global positioning system that directs your smartphone, tracks massive commercial shipping routes, and guides precision military strikes relies entirely on a vast, silent constellation of satellites orbiting the Earth at thousands of miles per hour. Because they are moving so incredibly fast, special relativity dictates that their onboard atomic clocks actually tick slightly slower than the clocks down here on the ground. Simultaneously, because they are positioned further away from the Earth's massive gravitational pull, general relativity dictates that their clocks tick slightly faster. If software engineers did not constantly mathematically compensate for these invisible, mind-bending warps in time, the entire digital infrastructure of the globe would collapse into catastrophic failure within 24 hours, sending commercial planes miles off course. Every time you open a digital map application, you are directly relying on the chalkboard equations scribbled by an obscure patent clerk over a century ago. When modern astrophysicists finally captured the very first terrifying image of a supermassive black hole, a monstrous gravitational singularity violently devouring light millions of light-years away, the glowing, highly asymmetrical ring perfectly matched the precise geometric predictions laid out in his 1915 paper. When massive, highly sensitive laser interferometers recently detected gravitational waves, literal ripples in the fabric of spacetime caused by the violent collision of two black holes, it was the final, resounding echo of his sheer genius proving itself right once again. He gave us the ultimate conceptual framework to fundamentally understand our reality, proving that space and time are not a rigid dead stage, but a flexible, dynamic, and violently active participant in the grand cosmic drama. Albert Einstein was not a god, nor a flawless, omniscient wizard. He was a deeply flawed, highly complex human observer who simply refused to blindly accept the surface-level illusions of our reality. He looked directly into the terrifying, chaotic abyss of the cosmos and found a beautiful, terrifying geometry hiding beneath it all. He demonstrated practically that the greatest tool humanity possesses is not a giant, billion-dollar telescope or a massive particle accelerator, but the quiet, relentless power of an unapologetic, deeply curious imagination. If unearthing the profound mysteries of our universe and dissecting the complicated, heavily flawed minds that actively shaped our modern reality stirs your deepest curiosity, make sure to hit that subscribe button. We are continuously exploring the absolute frontiers of history, science, and the hidden mechanics of our dark world. Join us and let us decode the universe together.